Okay, good morning, everyone. All audience, all audience that can join us in this event. It is the continue from the last week meeting. Talk about the benefits of the tactical motor used in the tractor figure. Uh, Maybe in this short session, I want to talk about discuss about the how is the vector space control and how to range and calculate and mount count each of the matrix multiply by all of the dynamics factor like three-piece source voltage like E source, B source, and C source like and how is then found out we can get the result of the output voltage of the vector that we can running to the motorcycle. I think the yeah, electric motorcycle and doing by the vector rotating like that is to uh, expose or the rotating magnet is done by the stator uh, running, yeah, rotating uh, from the static stator, but the magnetic field is also moving around the the, the rotor, I think, yeah. And at the same time, the rotor rotation should be balanced by the rotating of the magnetic field produced by the stator. And this is the goal that behind this discussing this today, and how to arrange that the rotating magnets uh, can adapt and balance the rotating of the rotor, uh, the amplitudes, the magnitudes of the vector. I think the the the, the amounts of the vector force or torque resultants, and also the speeds of the rotating magnet we close and similar with the rotating of the rotor. Okay, let me share my presentation. Okay, anybody can show and listen my voice, my okay, good. Yeah. Here, the front of you, we see uh, that so you know that in the controlling of the motor that we have, for example, there are three phase of the synchronous motor or uh, induction motor like this. They already have three source space or three frames of the electrical source and also the magnetic flux source is EBC here. And to control the motor, there are inverter like this inverter that construct of six of the IGBT. The IGBT is the power transistor that used to open and blocks the line of the DC current flow here. You know the top three top of the IGBT here we can also define as a top IGBT. This top, yeah. Then we have already three IGBT in there. And the bottom here is also we have already uh, three, also the similar numbers. And the top is three and the bottom is three. Okay. And here, each of the phase, like E, phase, I think the source of the magnetic or the electrical source, E and B and C here connected to the three IGBT. That means each phase has already two or a pair of IGBT. That is top one and the bottom is one. Okay, and as well as B and C. And here that I think that the same that I explained in the last week meeting before, that the order of the IGBT is open on close is we have six uh, sector. The sector one, under sector six, yeah, and all of the audience is already know and understand about what I mentioned and explained last week, 2 week. Here, for example, in this here is the B. That is this. Sorry, that is E. E pace here. E pace is now is on in the tops of the HPD, and the others for B. Yeah, B force and is now is in the bottom is active. That means is zero here. Zero means is the bottom is active, and then C also zero is active. That means in the bottom, and only one of the HPT still on. That means it's in the top. That's by belonging by E source. Yeah. Okay. And the important thing that the whole is to calculate the amount of the voltage here, voltage divided between the EBC, yeah, but with the border of the divided by two section of the voltage, that is top and bottom here, and in the middle of the bottom of in the middle of both top and bottom we have a neutral here, and here, for example, this is the mix of between the serial and parallel connection from the IGBT. That means from the top IGBT, then here connected in the serial position to the both IGBT, and the two IGBT is connected to the parallel, yeah, between B and C is parallel, but in between E to both of B and C in the serial form, yeah, okay. And to calculate the amounts of the voltage between top and bottom, so you see here, you know that we going to the bottoms bottom feature here. Here the E field, the E field coil, and here is B, and here is C. So somebody also, I think all the audience know deeply, know clearly that in this voltage dividing, the E have higher voltage mounts. That is two thirds, yeah, volt. And for B and C is only minus 1/3. Why minus? Why? Because the minus here mean that this position of the voltage is under neutral. Yeah, that's a neutral. Neutral is if we going to the bottom here, so min is minus. Yeah. Okay. And the voltage under the neutral position that here is mean is plus. Okay, right. That is the symbol, and the position the level of the voltage defined by the minus or plus. Yeah. For example, is plus 2/3, and the bottom is minus 1/3. Okay. That means here also we can more clearly explanation that here the E have higher, yeah, twice higher level voltage and the compared by the B and C here. Yeah, okay. The P and C have the same voltage because they are is installed in the parallel connection. Yeah, okay. Okay. I think it's clear. Yeah. I wanna go to the next section, next page. Okay. Uh, okay. Right. No. So this is the last page. It explains, it talk about the amounts of the voltage by B, C, or uh, B, E, D, or C. Yeah, the position level voltage belong to the E, B, C, as we have already mentioned and discussed it. Yeah, and now the finally that we you know that EBC is still in the format of the three frame. That means there are three frames. There we E frame and then B frame and then C frame. And to control of the motor, that's very difficult as the frame is divided in three frame in the same time to control that the voltage of the three frame. And to make it simplified and make it simple, then we have the method how to transfer from the three frame EBC to the one frame. That one frame is mean uh, here alpha beta frame. Yeah. Okay. And here uh, we already discussed last week that the factor of V, yeah, is equal with the voltage of E times the exponential factor. That means E, yeah, uh, 0, yeah, and then T, then plus B. That means the position is here, yeah, position is here. Why is 0? Because the factor here, the factor is uh, they have the distance from the normal line here is in 0. Yeah. Okay. And if the running and they turn to the next position of the phase here to B, this is 100 103 of the shifting from the 0, or in the radian is 2.2, yeah, radian, yeah, unity, but the degree is 120. And here symbolized by here the factor is E, yeah, well, G is the imaginary, as with the 2P avoid divided 3, yeah, okay. And if we going on next, moving to the next position of the C here, this is the factor is now is uh, moving, yeah, and then the changing to the position of the C, and then the factor is E, yeah, while J and for P 5 3. Okay, and the last one back to the position from the start, yeah, from the initial condition. That's going to the E. Okay, okay. And for example, we have if we have there are some factor right here. Yeah, there are some factor from here. Yeah, okay, that is the factor of P, for example, inverse by P. How many? How high the amounts, and the direction is okay. Yeah, that is okay, but the amount of the factor P is calculated like this. Yeah, that means E E here, you calculate here, he is here. Yeah, for example, position of V1. Yeah, V1 here. V1, position of V1 is here. V1. Yeah. Is the factor of E. E means here is 1 here. Okay. We have there are two of type of the metric of the metric, yeah, metric. There are the line to neutral voltage and the other is line to line voltage. Here, the if you measure correctly, yeah, then the E in the position P1, sector 1 atau V1 here, position 1, is the E voltage, yeah, is two, yeah, two-thirds, yeah, okay. Okay, and the others, E, B and C is minus one-third and minus one-third. You know that in common from the three source EBC is equal what? 0, yeah? Yeah. It is two-third and then minus one-third minus one-third is 0. Okay, that is the limited. We can see the balance of the three-phase voltage. Okay, let me make some pre picture here. Okay. So here, and then if we have this one, then here, that means uh, two-third of E time is here. Yeah, here. You know that. Sorry, I want to make some note. Yeah. Okay, right. Okay, good. Yeah. Here, the E power 0 is minus here. You see here. Okay, this is one. This one. This factor here. Okay, right. That means E time 1. Yeah. Okay, then you know that E is equal the cos 0. Yeah. And plus G or imaginary sin 0. Yeah. Here is cos. Yeah. Here is time by cos. Yeah, you know that means, one is E. That is E like this. Time here. Here mean is sorry, cos cos 1 cos cos in position of the 0 here. This position and the 0, yeah, position 0. Yeah, plus what is it? Plus G sin 0. 0. Okay, right? And then the equals cos 1, cos 0 is 1. Cos 0 is 1. And sin 0 is 0 here. Okay, right. Okay, and then continue. Yeah, next. P, yeah. Who is P? P is here. Yeah, okay, right. P here, yeah, is here. Is here. Sorry. That is P. And here is, sorry, that's E. And the last one, C, is here. Okay. This one. Okay, sorry. Here. This is C. Sorry. Okay. And we next, yeah. Continue. Okay, right. What is P? P here, okay, if we have find it, it's got it. There minus one-third. And then P time here. e power j to p power 3, that means this one. Okay, the position of now in the the next sector, I mean the p3, yeah, then here the p3, that here in the p1, the position, and here is, you know, this is this in the, okay, the p, the e, the position of this vector is this, minus a half, and g square 3, yeah, sorry, square 3, avoid 3 or 2, yeah. What was this amount is come from? What does it come from? This amount. This come from this, like similar with this. This cos of what? Cos here 120. 120. Okay, 120. Okay, and then plus, yeah, plus plus. Sorry, j sin, yeah, sin 122. Yeah, 22. Yeah, right. And the last one plus c here. Okay, c time this one here. Consistent. Yes. But this amount is, what does it come from? This come from here. This one. This is this. Okay. Come from this. Okay. And here is cos uh 240, 240, and then plus j, yeah. Okay. Sine, sine 240, right? Yeah, right. And then equal, and we can change this, this symbol, like here, it is, you know that from cos, yeah, e, can we can hear from e, uh sorry, vector like e is how much? E is here 2/3, yeah, 2/3, yeah, 2/3, 2/3 time this one, yeah, cos 0 is 1 time 1. Okay, right? Right. And plus 0, yeah, 0, okay, right. And then plus p is here, which is minus 1/3, yeah, this is minus, sorry, minus, this minus, sorry, minus 1/3 time here, minus a half, minus a half, okay, right, minus a half, and plus here g, yeah, plus g, uh 3, 5, 2, right. And the last one is C is also minus 2, minus 1/3, yeah. C minus 1/3. C is minus 1/3. Okay, right. Time in the ether, time is here, minus a half, minus a half. Okay, right. and then minus G, minus G, G, sorry, minus G, uh, 3 about 2, yeah, about 2. Okay. So now it's finished. Okay. And then by the calculator, you can calculate the amount of fee. Yeah. Here, the amount of fee you can calculate. And maybe there's the equal is 2 avoid 2/3. Yeah. 2/3 with the precision. Yeah. Yeah. 2/3 position of what is it? E0 P. Yeah. And can be symbolized by 2 third, 2/3, yeah, 2/3, sorry, 2/3, sorry, maybe it's more clearly here, a little bit, uh, uh, to up, yeah, so third, third, with the position of the vector as n0, yeah. Okay, right, that is simple solution, simple how to calculate the amount of the vector, yeah, the vector one here. The factor one here. Let's no, no, we achieve arrive in here. The calculation is this and this one. Okay, that with the amount of source B, C, and C in this like this EBC. Okay. Okay. And if we calculate all of the factor from V1 and then V2, V3 until V6, then finally we get totally in common like I wanna share to you, yeah, the content tag. Okay, let me uh, delete all this. Then we will do changing to the next page. Okay, thank you. Okay, and the next is like this. Okay, then start from the V1. Yeah, this, I think you can calculate the same all of that follow that what I have already done to make calculation finally from each of the factor like this. Yeah. This is from the factor, start from the factor one. Yeah. Factor one, do you know factor one? Factor one here. Yeah. This factor one like this. Yeah, this is factor one. Yeah. Factor one. Start from the V1, V2. Yeah. V1, V2, V3, and so on. Yeah. Then that's the, we have six vector position of the vector, I think. We have the three position of the vector start from the V1, V2, V3, and then V4, sini V4, V4, then V5, V6, and then back to the V1. Okay. So we're going to the next page. Then we get the finally of the all calculation of the all of the result of the calculation about the amount of the each position of the vector from V1 until V6. Yeah. Okay. Okay. Then we go on the next page. Okay, right. This you see here. That's very simple to calculate with the same method that was already done and I mentioned by to you. Yeah. That yeah. Here, for example, they start from the V1. Then you see here for the V1. V1 is the same. That is E. You know. No, sorry, that is constant number. That's constant number. Why? That is so a third is the constant number come from the current and convert to the voltage. That is multiply by 2/3. Yeah. Okay. The important thing that you should know that here in the two uh here to uh, to a third, this is that means it's here e, yeah, and time 1. You know that the e in the position of 0, e powered by 0 of g equal is 1. It really is 1. Okay, and the others is minus 1/3 is b. Here is e. So this is b. This is b. And the last one minus what is c. That's the. I think that you know all that. This I explained before. Yeah, last speak. Yeah. Okay, and then we going to finally here f we final completely calculated. Then you get 2/3 plus 0j. That means we have the real position of the uh, platform. That means then 2/3 is mean that the real position, the real frame, yeah, with the position of the vector in the direction is 0. And then we go to next to the vector 2, and then we get here. We get it here. Okay. The magnitude and the value, the amount of the vector, that means the long of the vector, is the same. It's 2/3, yeah. And then they said 2/3. But the direction is different. The P1 in the direction is 0, and the next to we talk and about the next or P2, the position of the vector, then the position changing from the 0 to the 60 degree. Okay. Okay, and then we can going to the next step. Sorry. So okay, right. Then it's the completely of the complete of the calculation. Then finally we get like this, yeah. Okay, but you should note that the take from the our calculation before, taken from the experiment to the calculation before that what was this? The sorry. Uh, the finally the results of all calculation amount of all of the vector we have they have the same magnitude, yeah, the same long, but the different direction here. Okay, that's the same line, but the different direction. The direction changing, shifting each of the position by the I think by here by 60 degree, yeah, 60 degree. Okay, right. And here the three vector 5, we get the same amplitude, 2/3 with the direction is 250 degree. And finally, for the vector 6, we get the 2/3, yeah, but the direction is the maximum. That means it's 300. Then going from the 6, vector 6, that's going to back to the vector uh, vector 1, yeah, okay, like this. Okay, that is the how to calculate the position magnitude and the position of the vector, the direction as well as the magnitude. Okay. I think that's all that I mentioned at the extension. The audience is know briefly and understanding. Yeah, that's my hope, because I explained so slowly, and because of the audience is the basic knowledge and the field of the audience is from automotive, is not from the uh, electrical engineering, like talk about the electric motor and so on. Maybe we start from the beginning. Yeah? Start from the basic of the calculation, no problem. Yeah. Right. And okay. Okay. Then finally, so we have the 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 final result of each position of the V1 until V3, V6, sorry, and we go around like this. So we go around because that if we identify, and we identify and then understanding about the how is the position, the vector, the position is moving, yeah, the position is moving rounds here, the moving this vector is moving, yeah, sorry, the vector is moving. That means the vector symbolized by the representation of the stator magnetic field here. Yeah. Okay. This vector here is repression of the uh, what is that? The magnetic flux of the result or resultant of the magnetic flux as doing by the static magnetic fields that they always rotating around the rotor. Yeah. Okay, right? Yeah, with the given speed. Yeah. So like this is rotating here, and the final goal of the calculation how to make between the rotating magnet of the stator here is the same with the rotor speed. Yeah, atau rotor rotating speed here, this rotor between rotor, and the different out shifting between the rotor and the stator of ma vector direction is perpendicular. Perpendicular, I mean 960, yeah, that's perpendicular. Then to achieve the maximum of the torque of the motor. Yeah. Okay. And here the former, how to calculate after after you get the here the component of the vector. Okay. For example, here the component is from the real number, the amount or the value is 2/3, but the imaginary, the position of the here, this imaginary here, this is imaginary axis, and then here is real, yeah, real. Okay, this is real, and then this is imaginary. The real is 2/3, and the imaginary is 0. Yeah, okay. And the position, the next position, next for here, that is different, yeah. For example, here, from the position of the vector 2 here, the real value is 1/3, but the imaginary value is 1 5 the power of 3, right? Here. Okay. And then next, from the position V3, and the real value is minus 1/3, and the position of the imaginary is 1 5 uh, power of the 3, right? Okay. Thank you very much. Maybe before we end our session, our presentation, our discussion, I want to show you about this. Sorry. This one. This is maybe the small complexity of the calculation, also the final result of the amount, each of the position. This is talk not only about the position of six, yeah, but also divided in twice, yeah, in twice, yeah, that is V1, and then in the middle between both of 1 and seconds vector here, we have here, for example, here is V1, yeah, vector, and then there's V2, yeah, yeah, and then we construct, and then we construct in the middle of both by P between 1 and 2. Okay, right. And between P3 here, P3, and then we, in the middle, we create the vector between 2 and 3. That's more, it's more, I think more completely and more perfect, yeah. That's and then and SMS as well as we did next, yeah. So and then we have P between 3 and 4, right? This is P 4 here, P 4, and then is P 5, and in between we have factor of 4, 5, and here is P. What is this? P. Sorry, maybe that is P 6, 6 here, and in between we have the factor of 4 to 6, and also finally we get to back to the initial factor P1. Then we get P 6 back to 1, right? And each of the position of the factor, like here or and here, so like this. So we can calculate with the method of the similar that I explained before. Huh? Okay. Thank you very much for your attending and joining us our short course discussing about the how to calculate the factor regarding the method to control factor by, we can call it the space vector modulation or space vector pulse width modulation. Okay, that we can discuss in the next week. Thank you very much once again and see you next week. Okay, have a nice weekend and be healthy and happy. Yeah. Okay. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.